In this video, we look at vector geometry, where vectors aren't represented on the Cartesian plane. In this case, it's represented on with shapes, and rather than writing a vector as AB is equal to some x and y in column vectors, well, that's the Cartesian plane. Vectors in vector geometry is written as AB is equal to some x or a or whatever, r or u or v. So a vector is represented by a variable a or b or something of the sort, a, x, or b, or any alphabet. You could have gamma, anything. So in vector geometry, we first look at equal vectors. We looked at equal vectors in vectors on the Cartesian plane. And we said two vectors are said to be equal when they have this same magnitude and they're going in the same direction. So, and then we have inverse vector or negative vectors, same magnitude but going in the opposite direction. One is the negative of the other one. Then we have multiple of a vector. One is longer than the other one, and they are parallel. Okay, so in this example, it says in the regular pentagon ABCDE, AB, that's from A to B, is equal to A. BC is equal to B, that's the vector, and CD is equal to C. And they want us to prove some things. Prove that AC is equal to A plus B. So this one here is equal to A plus B. What I normally do is extract those triangles that the vector forms. Those little triangles, I normally do a little extraction of them so it doesn't confuse me in the entire shape. A, B, C. So, which one is the resultant vector? I said in vector geometry, I said it in the other videos, that in vector geometry, we use, the only thing we use is the vector triangle law. For when you have to calculate anything, we have to use the vector triangle law. Okay, so the vectors that are going in the same direction as before, this is going with the arrow, going against the arrow. The one that is going against the arrow is the resultant vector. So AC is the resultant vector, and that is equal to A, the sum of the other two vectors, AB plus BC. So the vector AC is equal to A, because AB is A, plus B, because BC is B. Then they're asking us to find now the vector A to D. That's this one here, A to D. And again, I like to extract those little triangles. Alright, so we have A, C, D. And we know this is C. What is AC? We found that. That is A plus B. We don't know what this is. And they asked us to find AD. So which one is the resultant vector? These two are going in the same direction, so the resultant vector is AD, the one going in the opposite direction. And that will equal to AC plus CD, the sum of the other two vectors. AC is A plus B, and CD is C. So we prove that AD is equal to that. And the last one they asked us to find is BD. B to D. This vector there. And we have to prove that is equal to B plus C. Or you can do that. That's simple. So let me just extract that there for you. This is B, C, D. This is B, this is C, and this is the resultant vector. So, pause the video and do it. And then you'll get the answer now. So BC, the resultant vector, is equal to BC BD, the resultant vector, is equal to BC plus CD. So BD is equal to B plus C. So in vector geometry, the thing we use the most, or almost all the time, is the vector triangle law. Okay, so in this example 9 on page 1155, we said the triangle ABC, A to D is equal to A. So from A to D is equal to A to E is equal to B. That's equal to B. D is a point on AD such that A to D and D to E is 1 to 3. So from this point here is 1, and from here to here is 3. This point A to D is 1, as the ratio would say. A to D is 1 and A to D is A, and D to B is 3. So if A to D is 1, and that is equal to 1A, and B to D is 3, then B to D has to be 3A. I hope you understand that ratio. And the same explanation goes for this one. If A to E is 1 and E to C is 3, then E to C is 3B. So how do we get that? How do we know that is so? Well, when anything is broken up into a ratio, right? If we share $100, let me see, $100 at a ratio of 1 and 1, right? We're sharing this half and half. We're sharing it at a share of 2 shares. 1 and 1 is 2. So if I want to know what is this for a share, is 1 over 2 times the 100, and I'll get 50. I'll get half. If we want to share $200 at a ratio of, but I want you to know that we're sharing the same thing. We're sharing money. So this here is sharing the same thing. It's sharing A at 1 and 3A. So I hope that old money explanation explained why this one is 3B and that is 3E. So we now have to prove that this line here is parallel to this line here. And if you look back, you'll see that this is this here, multiple of a vector. So how do we prove that vectors are parallel? Well, they must have something in common. In function, when two vectors are parallel, they have the same gradient. So there must be something common with these two vectors in order for them to be parallel. Well, let's see. Here is the question. Here we go. Let's find BD first. So if we extract the triangle, as we should, ADE, the vector said A to D, so the vector is going down from A to D and A to E. So it's going down A to E. Which one is the resultant vector? Which two is going in the same direction? This one is going with that one. So AE is the resultant vector. This is A, this is B. We don't know what that is. So AE is equal to AD plus DE. We know AE to be B. We know AD to be A plus DE. Take off that. Good. ADE is equal to that, B minus C. Now let's find BC. Well, we're looking at the entire big triangle now. So we don't have to extract that, but if we do that, let's see what will happen. What will be from A to B and from A to C? From A to B will be 4A. Why 4A? Because this piece is 1A, this is 3A, so the entire thing has to be 4. And this is going to be 4B. So we want BC. So again, which one is the resultant vector? These two are going in the same direction, so AC is the resultant vector. BC. The resultant vector is equal to the sum of the other two vectors. So, what is AE? AC 4B is equal to what is AB? 4A plus BC. And this comes over, becomes 4B minus 4A is equal to BC. So, how do we know these two are parallel? Well, let's see if something, this is DE, is equal to that. Let's see. If these things are parallel, one, they must have something in common. So, let's say DE is equal to BC. Not necessarily BC. Oh, let me put it this way. DE is equal to what am I doing? BC is equal to, this is common, right? This 4 is common, so we take out the 4 and we'll have B minus A, right? So BC is equal to 4B minus A. But isn't DE B minus A? So BC is equal to 4DE, because DE is B minus A. BC is equal to 4DE, which means they are parallel. They have this in common. They have, we can say, the same gradient, but this is not gradient in geometry. Okay, so that's how you prove vectors are parallel, and we already did this one here. If BC is equal to 4DE, then if you take the 4 over, then BC divided by 4 is equal to DE. So that's what they want you to do. One is a fraction of the other, right? And this is how we know that they are parallel. They have that thing in common. They have the same vector, but one is just bigger than the other one. Okay, so look at this example. And in this example, I want you to observe some things. I didn't write the question. I want you to observe some things. Can you see what are parallel and what are not? So this vector asks us to find the vector AH. This vector here, from A to H, from A there to H. AB is equal to A, BC is equal to B, CD is equal to C, and DE is equal to D. If you notice, DE is parallel to AH. If DE is parallel to AH, then they are equal vectors, and they have the same size as well. So AH is equal to DE, which is equal to the vector D. Right? AG, HG, this one. HD is parallel to CD, so this one is equal to C. It's equal to CD. EF, this here. Now we talked about inverse vectors. As you can see here, this is going in that direction, this is going to this direction, so EF is negative A. If they're inverse vector, one is the negative of the other. We said that. It's inverse or negative vector. So if this one is A, and this one is going in the opposite direction, then this one is negative A. If this one was A, and that one was going in the negative direction, then that one would have been negative A. Okay, so now we ask for FG, F to G. Again, this one is negative to that one. You can see that. So this one will be minus B. Now they want AHC. Okay, H to C. From H to C. I want you to observe that there is nothing we can do there. That's a trapezium. That is a trapezium. There's no trapezium law of vectors. There's only parallelogram law of vectors and triangle law of vectors. So how do we get from H to C? Oh, this is what we do. We create two triangles. We create two triangles. If we find what AC is, then we can use this triangle here. This is already D. We can use, I'm thinking I draw this too small and confusing. Let me do it back. Good. A to C is that. If we find A to C, we can use this triangle at the bottom here to find this along one here. So let's find what AB is, AC is. AC is the resultant vector, so AC is equal to AB plus BC. And AC is equal to A plus B. So we have that. Now, we can use this triangle at the bottom here. This is A plus B. You can abstract that little triangle if you like. So now, which one is the resultant vector for that one there? So we extract it, and which one will be the resultant vector? Which two is going in the same direction? AC and HC is going in the same direction. So the resultant vector is AC, sorry. And that is equal to AH plus HC. So AC is A plus B equal to AH is D and plus HC. This comes over. AB, A plus B minus D is equal to HC. And that is your vector. So then GD. GD, this is the same process, but you're doing it at the bottom. Right? So I'm going to let you do that one. They want from G to D. So again, you can use this small one here. This is minus A, and this one is B. Sorry, minus B is inverse to that. And then you can get GE. Well, GE will equal to, I'm just going to write in the answer, but you pause, extract this bottom here like I extracted this one, calculate it, and then you correspond the answers. So GE is going to, which one is the resultant vector? Oh, sorry, this one has no resultant vector. All the vectors are going in the same direction. So what we can do is this. When we extract it, put this way. I'll have to do that. So I extracted it. Now I'm putting the vectors parallel to the vectors at the top. So this one is going in that direction. So this will be B. I changed this around. This one is going in that direction. So it will be A. And then if you're finding GE, GE is not the resultant vector. Yes, GE is the resultant vector. So GE is going to be A plus B. If that is A plus B, this is D, and you have to find this one here, GD. You're going to get A plus B minus D. How do I know that? Without any calculation, these two are parallel. You ask it for HC, they ask it for GD, and they look parallel. They are parallel, so they'll be equal vectors. And then BF, from B till up here to F way down there. You have a lot of calculations to do. So let me show you what you have to do first. First, you have to find what this one is, B to D. That is going to be B plus C. B plus C, because those two are going in the same direction. Then you have to find B to E. And B to E is going to be B plus C plus D. Because this here and that is going in the same direction. Then this comes in, this will be E. If you want a B to F, these two are going in the same direction again. It's going to be B plus C plus D plus E. So this is your answer for B to F, but extract and work. Okay, so we have one more to do in this video. This is on page 1150 something. And then we're going to start working some past CXC papers. That will be question year 2017 and year 2016. For this video, we'll do this one here. Okay, so we have this triangle PQR such that S is the midpoint of PQ and XY are points on PR such that the ratio is 1 to 1 to 1. So they are in 3 equal pieces. PQ is X. From P to Q is X. If from P to Q is X, then here has to be half of X. And here have to be half of X too. Because it has to, these two must add up to only X. If from here to here is X, from P to Q is X, then here has to be half X and half X to get to 1X. PR is Y. From here to there is Y. This entire thing is Y. 1Y. So how do we get a different section? Well, if the ratio said there are 3 equal pieces and this entire thing is Y, then this is 1/3 Y, 1/3 Y, and 1/3 Y. Because when you add all those 1/3 Y's, you'll get back your 1Y. So the questions are simple. We have to express QR, so you have to find the vector from Q to R. The vectors are going in that direction. We want Q to R. So the big triangle there, let me extract that big triangle. No, it is wrong. This has to come down some more. Good. So P, Q, ignore this here, R. This entire thing is X, this is Y. Which one is the resultant vector? Which one is going in the opposite direction? PR. So PR is equal to PQ plus QR. PR is Y, PQ is X. We don't know what QR is. You cannot leave these arrow out. It's not vectors if you leave them out. So QR is Y minus X. Easy stuff. Then they want RS, from R to S. So from R to S, let's extract that again. Why am I drawing this thing wrong? Bum. S here, Q there, R here. So from R to S. From S to Q is a half X. From R to S is what we're trying to find. Good. We already know that from Q to R is Y minus X. So RS QR. Isn't something wrong there? Something is very well wrong there. Because this, if I draw this here, you will have no resultant vector. Everything will be going in the same direction. So what I'm going to do, I'm going to put this as SR. I'm going to assume that the textbook made a mistake and asked me to find RS when they meant SR. So which one is the resultant vector? SR will be the resultant vector. So SR is equal to SQ plus QR. So SQ is half of X and plus Well, QR is y minus x. Half of x minus x plus y. This will leave me with minus half x plus y. So this is what QR is. In mathematics, it is generally accepted that you put the negative term at the back. So y minus half x. So that's those two. Now we have to show that qy from q to y, dear, is 2 times q to x. What they're really asking you to show is that these two vectors are parallel. So first you have to find q to x. What is q to x? Pause the video, find q to x. Extract your little triangle, PSX. Extract that little triangle at the top there and find q to x. I'm just going to write the answer. The resultant vector here is px is equal to ps plus sx. So when you bring that over, you'll get that px is 1/3 y, and when this comes over, this is sx. ps comes over, ps comes over, and that is the half, so it becomes minus half x, and that is sx. If we were to extract the triangle PQY, because we have to get the QY, PQY, we found SX, now we're finding QY. PQY, the resultant vector will be, from here we can see that PQY, PY. PY will be the resultant vector, and that will equal to PQ plus QY. So we now have to find QY. PY is 2/3 y. Y 2/3 y. This is 1y. This is 1/3 and 1/3. 1/3 and 1/3, when you add them up, LCM, you'll get 2/3. When this comes over, this will be minus x equal to QY. So how do we prove that QY is 2 times SX? Let's take out 2 here. If we take 2 out here, if we say 2 is common, we take out that 2, then we'll have 1/3 left, because 2 times 1/3 is 2/3. 1/3 y. If we take out a 2, then this becomes half. Why does that become half? Because 2 times a half, 2 cancel the 2, you'll get 1. So you'll get back that 1 that was in front, that x. And we can see that this here, QI, this 1/3 minus half is the SX over here. So this 2SX is equal to QY. And that's how you do vector geometry, representing vectors using variables and fraction, which can be confusing at times, but you can do that.